Hello and welcome to another exciting Blender tutorial. Today I'm going to show you how to get motion blur to work across cuts. Let's get started. When you're creating short films and stuff, it's really helpful to have a little bit of Python in your back pocket because Python can come in like a charm in a situation like this. So let's do some Python. I bet you didn't expect this coming. That's right. Hello, it's a Python tutorial. Oh, cool. So I'm making progress with Dump Run, the short film that I've been working on for way too long, and it's getting there. Anyways, I've got a render of the second scene, which I've now finally finished the second scene. I'm just starting the lighting phase for it. So if you're interested in finding out more about Dump Run, you can check it out over on the Blender Marketplace. Now, that's where I've got this as a product. You can buy and get all the project files, and then to follow along with the tutorials, you get all the tutorials to download as well. So you can have all of it offline and just go through the entire course. And as I complete each scene, I'm uploading the final Blender file. So in the end, when I'm done with the whole short film, you'll have everything. But you already have all the things you need to make the film because I've got all the assets, the characters, the sets, all the stuff is uploaded, ready to go there. And you can use those to follow along step by step through all the tutorials. Now, all the tutorials are available for free here on YouTube. So you can watch those videos and make it yourself following along for free. So that's totally free. But if you want to get the project files and you want to have the course material downloaded off the web ad-free, that's where you have to head over to Blender Market. You can buy it there. And that really helps support the channel too. So if you want to show me some love, head over there and consider picking up the course. Now, what I've got here is the render of the second scene. And I'll just play through it real quick, but I've got some problems. Let's have a look at the second scene real quick. So I'll hide this one. So let this cache. So no sound, no audio yet. It's dropped down. There you go. Second scene, it's come together. There's a few notes, a couple of things I want to change about this, but I'll talk about that in another video and how we're going to move this thing forward. Again, this is the rough initial lighting pass, or just kind of the default lighting setup that I've been using, and I'm just seeing how it all plays out to try and catch problems. But one of the problems I've caught is this one. So let me just unhide this. This is an older render, and what happens is you might run into this a lot. If we go through, I'll find a cut where it's really visible. Let's see, it's going to be really visible on this one, I believe. Yeah. So if you see here, he lands in this, and I'll go frame by frame. I'll just make this full screen so you can see this a bit better. So he lands, and then right before the cut, here's the cut. You can see how everything moves. We get this motion blurred frame. Now, what's going on here is that I've adjusted the position of this pile for this shot. And so it's moving quickly over one frame to get into position because I've got this cut right here using a camera marker right in my scene. So all these are with camera markers in my timeline. And so the cameras are switching. And sometimes I make little adjustments to the objects and the props and things on a per shot basis. And it creates these artifacts where you get these single frame blurs across certain things like that. Okay, there's another example here. I'll just go back to the previous cut. So this one, he smashes down, but you see, as soon as we cut, things aren't really moving. Like there's a little bit of motion blur here, but then there's a lot. So there's this like, boom, huge jump in motion blur. It's a bit inconsistent. And so every time you make a tweak, you make a little change to an object that happens across a shot and it happens over one frame, right? You'd think that, you know, it's not noticeable when you're watching the playback, right? But when you turn on motion blur and you render, it is going to be noticeable because Blender is looking at the fact that this object moves a whole lot in the span of only one frame. And so in Blender's calculations, that means that, hey, there's a lot of motion blur here. So this is a classic problem that you run into a lot whenever you're doing multiple camera shots and you're rendering them all out together from one scene. But there is a workaround, and I've figured it out. I want to share it with you. So over here in the settings, we've got the motion blur settings. So if I go to my render settings, so here are in Eevee, and this works in Eevee and in cycles. So I drop down motion blur, and there's this option here called the position. So we have center on frame, and we've got the shutter, background, a bunch of other things, mesh snips, but the center of frame is the key. We've got center of frame, start of frame, and end of frame. So each of these create a different result. So let's head over to one of these cuts. Let's see, I'll go back into my scene. So just switch over to my 3D viewport. And let's find one of these moments in the scene itself. So let's see, that was right. It was right over here, wasn't it? This one had it. So between here and here. So this frame has a big motion blur. So let's just see what happens. We'll go start a frame and we'll render this. So I'll go render image. Wait, there we go. So we can see we've got this massive motion blurred frame. So I've got 3 different renders here. And this first one is when the motion blur is calculated at the start of the frame. So we get to the beginning of the frame, we calculate the motion blur. This one, it's a little bit different, is calculated on the center of frame. And the end of frame, naturally is using the end of frame to calculate the motion blur. Now we can use this to create clean frames across these cuts. And let's have a look at what happens to this. Just find this rebel file. Let's find the actual object that's getting moved. So I'm going to select this object here, and you see this sheet metal object, right? Here's my camera cut. So I'm on this camera right here for this whole section, right? This whole shot. And I get right to here, and I've got this keyframe for the panel saying, hey, this is the position I want this panel on the last frame of this shot. Then I move 1 frame forward, and now I have a new marker, and it's moved to the cut. And now the panel's in a different spot. So it's over here because I wanted it just a different composition for this particular shot. So you can see the problem. When I'm on this frame, we're getting the bad render, okay? And the reason we're getting the bad render is because our motion blur is set to start a frame. Okay, so let's go to the next frame. We've got our camera cut, and let's leave it on end of frame and see what happens. Anyways, so when we set it to end of frame and we come to the start of one of these cuts, we're going to get a really blurry frame. So it's the opposite effect that we want. So when we get to the start of a shot, we need to switch it back to start a frame, and let's see what that looks like. There we go. So now it's clean and correct. So you can see the problem. When we get to these cuts, we need to have a switch between these 2 different render styles. Because we know that every time we hit a marker, we're going to have a blur problem if we've moved anything. However, if it's the frame before a cut, if we use the end of frame motion blur calculation, we'll get a correct frame. At the start of a shot, we want to make sure we have start of frame as the calculation. Everything in between doesn't really matter. But for consistency, we might as well just leave it on start of frame. So that means that the only time we need to really worry about switching this is when we get to the frame before a cut. And in those moments, we need to set this to end of frame. And everything else we can leave at start of frame. Okay. Now with this knowledge, what we can do is we can render out our entire sequence and then go through to each cut and go back a frame, switch this to end of frame, and then render out these individual frames and just save over the old ones, and we'll have an image, we'll have a full render that looks really nice and clean, where we don't have these problems on the cuts, right? Every cut, no matter how much we take, it's going to work. So that is a really, really helpful thing to know. However, it's also a pain. So that's a big process to go through and do that every time. What if you have hundreds of cuts? It's going to take you forever. Well, all right, so we got our dub sheet. First thing I'm going to do is I'm going to switch over to the text editor. And we're going to give this thing a name. We're going to call this motion blur cut fix .py. So what is that? The .py is the file type for a Python file. And this is helpful because it just helps Blender know what it is that we're looking at. You could call this txt or whatever and write the code in it. It would still run, but it's just better to call it .py, then it's really clear to the system what it is and what we're trying to do. Okay, so you may not know how to do any Python whatsoever, and there are some basic things that you can do to figure your way out with all this stuff. I'm going to try and break this down and make this as simple as possible. All right. There's a lot of stuff here to learn. If you've never done Python before, this is kind of a deep dive, but at least you know how to do the render without Python if you don't like it. But every Python script starts with importing all the code. Basically, all the commands we're going to use, they live in a file somewhere on your hard drive. And Blender knows where they are, but it doesn't bother, dealing with them or whatever when you're creating a script like this, unless you tell it specifically to bring it in. We can say, hey, look, we're going to be using all the Blender code for this. So we need to bring in all the Blender code so that you understand the commands that we're about to use. And the way to do that is we go import. That's the command in Python to bring in something. and we're going to type BPY. And BPY is the name of the file that has all the commands in it. So it stands for Blender Python. It's just a shorthand. So now we've imported BPY, and now we can create any kind of code we want. And usually all the commands start with BPY, and then you hit the full stop with the period key, and then you can type in, whatever the command is that's after it. And the way Python works, it's like a little file folders director. So BPY is the top level directory, right? And then each command is like a folder inside it. And instead of slashes to say, look inside this folder, use little periods, little full stops. So each of those goes a bit deeper into BPY and pulls out a certain command. Now, the best way to do Python, let's split our view. We're going to create a Python console. So that's here in the scripting panel. You can also bring up the info panel, which sometimes is helpful. This will tell you like the actual Python code that's executed when you do certain things, but it doesn't tell you everything. It just tells you some things, so it's rarely useful. I find that I don't really use this very much, but you can see what I've been talking about, right? So bpy.context.area UI type info. It's about a lot of mumbo jumbo, but this is basically what happens in the code whenever you switch these things. So if I switch this to text, boom, you can say bpy.context.area.ui type equals text editor. I could copy this, come over here and paste it. And now every time I run this code, it's going to swap to the text editor. So we're already on the text editor, so it's not going to do anything. So if I made this something a bit more interesting, like 3D view, right? And copy that instead and paste it. When I run this, ta-da, switching to the 3D viewport. Wow, Python. Back to the text editor. That's not what we want to do, but at least now you understand what's going on. So I'm going to go back to the Python console, and I'm going to get rid of the info panel. So what's useful about the Python console is you can kind of poke your way through the dark to try and find the command you want, because you've got no idea what's in BPY, right? If it's a file folder with hundreds of files inside it, each one is a command that can do something. You got no idea what you're looking for. And the best way to find them is to come over here and you start with the first one. So we're going to go BPY. It's already imported when you're using the Python console here, so you don't have to type import. And then we're going to hit the full stop key, and then we're going to hit tab. And tab will basically open the directory and show us, here's all the commands you could use. So this is every possible command that I could put in after BPY. So there's not thousands, there's just a couple. And what we want is a specific one. We're going to, usually you look in context or data, or that's really it. It's usually those two, context or data. Sometimes you use ops. Ops is where a lot of the commands live for like doing stuff like entering edit mode and stuff, but it's pretty rare. Usually you can do most of the code with data and context, okay? Now, let's figure out how would we create a Python code that will switch the in frame and the start frame, right? Let's work it out. The other thing we could pull up, let's pull up the info panel. This could be helpful for us. Let's just switch this right at the start to see if it tells us anything. So I'm gonna go start a frame. Hey, wow, cool, that's really useful. bpy.context.scene.ebmotion blur position equals start. And then I imagine this will be equals end. Yeah, so this is the magic code we need. So let's just go ahead and copy this. So just select these two, come over here, paste them in. So I know I've got what I need over here, but we don't have everything, right? Because this isn't going to render anything. This is just going to change these guys. And we've got some conditions. We need to say, well, if we're almost at a camera marker, we need to change it. But if we're not, we need to leave it. We also need a way of like going through every frame in our animation and rendering. So one thing I know is if I go up here to render and render animation, it's just going to run an operation. You can see the Python tooltip there. Oh, let me show you too. If you go up to edit preferences and we come over here to interface, you can come over to Python tooltips, turn those on, as well as developer extras. Those are helpful. They can give you a bit of extra information about the Python code that's in operation. So anyway, so we're going to come up and we're going to say, all right, if I go render animation, it's just going to render, right? And it's not impossible, but it's really advanced to insert code into one of those kinds of operations so that it will do something else whenever it renders. So it's kind of like going into like the bedrock of what Blender is made of and changing that fundamental Python code. So that's a little too advanced, a little too hard, but we don't need to go that extreme because we know that if we go render image, it will render a single image, it will use motion blur, it does everything that it would do with the full animation, but it's also, a bit more containable. So that will allow us to just render one frame at a time. And you can see, we can see the command there. If I hover over it, it says bpy.ops.render, and then it's got some brackets and use viewport equals true. Now what we can do is we can come up here to this render image, and because we're seeing the Python tooltip, I can right click on this and I can copy the Python command. So I'll copy that. I'll come up here, paste it. All right, so we're making progress. We got some good stuff. Now what we need to do is figure out where all of our markers are. So I'm just gonna bring up my view a little bit, just back to flat shaded mode. And I can see all these markers. So we need to figure out how to get to these guys. I'm going to switch to, let's see, timeline. Now, I'm going to save you some time. I'm going to tell you how to get there, because otherwise you're going to poke and prod for a long time to get where you need to go. So I'm going to come over here to the Python console, and I'm going to go bpy dot, all right, so data, when you go bpy.data, you're going to access everything that's in your project file, not just the scene you're in. Because remember, you can have multiple scenes. I've got this master scene file, and I've got other scenes. So there's a lot of scenes that you can have in a file. And each of those scenes might have different objects in it, might have duplicates of the objects. Some of those objects might be linked to other objects. So there's a lot that lives there in the scene stuff. So data, bpy.data will let you access everything that exists. So for example, I could go bpy.data.objects, which is one of the commands. If you don't know, you can go data, hit tab, and you can see there's a lot of commands that live here. Not an impossible amount. You could explore these, and some of these make sense, like, you know, collections. Okay, well, maybe that's how I can interact with collections. But if I go bpy.data.objects, and then if I don't know what to do, I can hit tab again, and it will suggest, hey, this is what you should do. You can see it's listed every object in my scene by name. And it's got a specific syntax. So it's got like the name of the object. So maybe I wanted to grab one of these wires. So I could start typing wires. I could hit tab again. It'll narrow it down further for me and fill in what it can. So wires, okay, great. Then I need to do, let's see, let's do dot zero, 0, hit tab again, 1, there we go. It does another little quotation and then a bracket. So if I hit enter, it will run that command and it doesn't really do anything. But what I could do is I could go into that, and now I'm going into this specific object. And I'm saying, oh, here's all the stuff I can do to this object. Hey, this is cool. Maybe I could change its location. Let's see. Or maybe I could select it, or, you know, you could do all kinds of stuff. What we want is something that's specific to this scene. We don't want something specific to every scene. We just want something that's specific to this scene. And the thing that is specific to this scene are these camera markers. So these camera markers just live in this particular scene called master scene. So I need to do some exploring about the context that I'm in, that I'm running this code from. I could go object, so bpy.data. I think scenes, right? And then hit tab. You can see I've got both scenes, master scene and master scene no edit, which are the two that I have. So I can go ahead and grab this one like this, right? And now I've got all the different commands that I can run on this particular scene. But you might not know what the name of this scene is, right? So, oops. So the best way to kind of bypass that unknown bit is to use the context. Context basically means pull up the data for, context here. Pull up the data for whatever scene we're in. So what's the context? Where are we at when we're running this code? We're in this scene. This is the context. So this will allow me to just select the stuff that's here. Now, what we want to do is we want to specifically hunt down the camera markers. So mode, no, not markers. You can see how I do it. I just guess, type in something, and I hit tab and see what comes up, or pointing me in the right direction. So if I don't see anything that's like really obvious, that's going to get me where I need to go, this is the point I just switch over to Google. I can type in anything I want and say, okay, how do I get Blender Python? Usually I type Blender Python and then I'll type what I'm looking for. So Blender Python, how to get camera markers, right? And someone will know and they will have posted about it. And you'll get the code and you'll go, oh, that's the command. And then it'll save you so much time. Okay, so a quick Google reminds me that what I actually need is to type in bpy.context.scene. So that was the bit that was missing. So bpy.context.scene. You can see, there we go, scene. So this will grab whatever scene is the active scene. The timeline markers, you can see I just typed in TIM and then hit tab and it filled it out for me. Naturally, if you don't remember that, you can just hit tab and look through all of it and it's gonna be here. These are in alphabetical order as well, makes it a little bit easier to see. But there we go, timeline markers. If I saw that, I'd go, oh, this is relevant. So I'm gonna have a look at what's inside that. So let's go timeline markers, hit tab, and okay, we've got this little box thing and then this here. So what's this telling me? Okay, whenever you see these square brackets in Python, it means that what you're looking at is something called an array. Now, an array is a variable, and a variable is something that stores a value. So x equals 10 means that x is a variable that holds the number 10. So whenever you use x, the software will substitute x for 10, basically. So you could go x plus x equals, and it will tell you 20. You can change variables and put things inside them. An array is a kind of variable where instead of just one value, it's got a whole set of values. So you might have the numbers 1 through 10 in an array. So in the first field of the array, you might have the number 1. Second field would have number 2. So you could have x square brackets, and then you could put in that square brackets which number of the array, which field of the array or entry in the array do you want to access. So if I, did the square bracket and hit 0, right? So x square bracket 0, it will grab the first index of the array. And if we put 1 in the first index of the array, then it would give me 1. If I went 9, it would give me the 10th index in the array. And if we put 10 in there, it would give me 10. So it's like putting a bunch of variables into one. Timeline markers is a variable that stores all the markers in my scene. And that's how we get all these weird dash things. Basically what it's showing me, this is a little confusing because all of these have the same value for the name, and that's what it's trying to actually show me is the name right here. We got one here, F1205. None of the camera markers have names. And in Blender, what's going on is the camera markers have something else. So let's actually just bypass trying to use a name, and let's put a field in there. So let's just put an entry into one of the index arrays. So we'll do 0. This will grab the first. So arrays always start with 0, and they go up from there. So let's have a look at what's inside array entry number 0. If I hit tab, I don't get anything. If I do full stop and hit tab, there we go. So now we're looking inside of this first part of the array, and we get all these different options. And we've got a thing here called name. If I type in name, you'll see that we get that blank double quotation. So there's no name. But if I look for camera, which is another property you can see listed up here, and hit that, it's going to be giving me the name of the camera that's associated with the 0 marker. So scene 100 v1 wide. So where is that? That's going to be over here. Scene 100, scene 01, 0100 v1 wide. So this marker right there. Now I can also find other information. You notice in the list, we've got, frame. There we go. So we can hit F, tab, and tell me the frames. So 448, and that is the exact frame that this marker's on. If I was to move this marker like to 449, and we run that again, I'm hitting up on my arrow key to go back to the previous command. You can see 449. So the array timeline markers holds all the markers in my scene. And in each of those markers, I can access the name of the camera that's bound to it. I can tell you what frame it's at, all the information I need. And we're going to use this information to change these values as we render. Okay, so let's go ahead and copy this because this is important. We're going to come over here, highlight this, right click and copy. And we'll put it up here in our little palette of important commands. And we got the frame. Awesome. Okay, now, so what we're going to do is we're going to build some Python code that's going to grab first the frames of all of our markers, and then it's going to move us to whatever frame's next in our render and render out each image. And we're going to run this command, the ops render viewport true. So this is the one that renders like just a still image, remember? So we're going to do this each time and run through it. Okay, so there's a couple of things we need. We need to know what is the start and end point of our timeline. So let's get that. We're going to grab the start and end frame. So again, let's have a look at how we would find that. Let's go for, well, first we could just try hovering over something. So our start and end frame, I'm going to hover over this. And here it is, bpy.data.scenes, master scene.frame end. So that means I could come over here and I could type in bpy. If I don't know the name of the scene and I just want to go, actually, we're just going to do context scene to grab the scene that we're in already. And now I'm going to see if that same entry is available. So let's come over here again. Let's look. So frame end. So dot frame end. Yep, look, there's a bunch of different frame commands here. So frame end, and boom, there we go. We've got the number. It works. So actually, I can go start, and that gives me the start frame. And then we also have frame current. That gives me the current frame that we're on. So we got all the info we need. So I'm going to grab this one, copy that, and paste that. And then we're going to have, let's see, frame start, copy that, and frame end. Now, there's another command I know that we need, which is setting the frame. So we're going to go frame set. And this one's a little different. This will actually ask us for a number. So I could say frame set. You can see this isn't square brackets like we had before. Whenever you see the curved brackets, I don't know what these are called, parentheses, right? No, that's quotation. Yeah, parentheses, yeah. Whenever you see these, it's something called a function. And a function is a bit of code that will do something. So it's not just a variable it's storing a value. It's actually a bit of code that does something. So it could like change the values in a string where everything's capital as opposed to lowercase. Or it could be a function that takes two numbers and divides them by each other, right? So it does something. In this particular one, when I hit tab, it gives me this info where it says frame, comma, subframe equals 0. And then it gives me a bit of instructions, set scene frame, updating all objects immediately. So this is how you can set the current frame and update all the objects in your scene in relation to it. If I was to set frame current equals something, it doesn't really update the scene. It's kind of just something it does in the background. So it's more effective to use frame set. And that's just something I've learned over time. So, but to learn how to use it, we just need to follow these instructions. So we need to give it the frame. So I could say 451. And sometimes with these functions, you get multiple variables, right? The second one, subframe equals 0. I don't really need to worry about any subframes because I just want to move to the whole number frame. So I can disregard it. So often you can do that with functions. You could just leave something out when you run it. So I'm going to put this in parentheses and run this. And it worked. There we go, 451. If it didn't work, it would throw an error and usually tell you what you did wrong. So then you go back and try something else. Sometimes with these functions, you'll need to type in things like frame equals 451 to get the correct result. But in this case, it works whether or not you do that. Okay, so we're going to grab this one, bpy context.scene frame set, copy, paste that here, and do the little quotation marks. I'll just type in frame here just as a reminder that, hey, that's where, or maybe f is what looks like a variable. That'll be a reminder for us that we need to use that. Okay, so we've got everything we need now, I think, to do this. So now we need to tell Blender to get all the frame numbers. So let's see, let's talk about how we're going to make this flow. First thing we want to do is we want to make sure we're at the start of our scene. So maybe what we should do first is set the current frame to the beginning of our frame, just in case the playhead's off somewhere else when we hit the render. So let's do that. Let's go frame. So we can just copy the code. We go bpy context scene frame set, paste that up here. And we want to set the frame to the start frame. So I'm going to grab that and paste it there, and that will work. Now we'll run this function. It'll look for the frame start, get that number, and then it will put it into here and run it for us. So this will set the playhead to the beginning of our scene. Okay, so great. Now we've done that. Now we want to render this frame and then move forward. So in order to do that, we need to create something called a loop. Now a loop is when you take, you tell code to basically repeat some steps over and over and over and over until a certain condition is met. So we're going to create a loop for this, and we're going to set some conditions. All right, let's get the total number of frames in our scene. So let's create something. So we'll create a variable. We'll call it total underscore frames, and we will set this to, so what would be the total frames? Well, it's going to be the start frame minus the end frame, or actually the other way around, because we don't want it negative. So end frame minus the start frame will give us the total number of frames. So let's go for the frame end, paste, and then let's hit the minus symbol, and then we go for the start frame, copy that, and paste. And there we go. So now we've got something called total frames. Now, if we want to check the code to make sure it's working, we can type this in print, and then we're going to type in total frames. And this is going to print this number into something called the console. Now, what I'm going to do is I don't want to use any of this code yet, but I want to test this a little bit to make sure it works. So if I don't want this code to be executed, you just hit the hashtag symbol in front of it. And this is the syntax for creating a comment. So the idea behind these is you can do a hashtag and then type in, hello, how are you? This is what my code does. And you could explain it, right? In a couple of more lines and write it all out. And it will always, the code will always ignore whatever's after these. So this is something that you can do to make your code a bit more readable. So we could come up here and we could say, first, get the total number of frames in the scene. And this is great because now if anyone comes and looks at our code, they can figure out what's happening. So we'll keep that. And we have print total frames. Now this is all that's going to happen in our code is it's going to get the frame in, the frame start, subtract them, and write something that's total. So let's print that. So let's run this bit of code. So to run the code, you click the play button. So click that. We didn't get any arrows, but nothing happened, right? So in order to see what it's actually done, we need to pull up something called the console. So let's go up to Window, and we're going to toggle System Console. And that will bring up this beautiful piece of window. So lots of crazy stuff. I've got some warnings here, but we can just ignore that. That's a lot of times you'll get warnings for different things if you've got like some add-ons or something that aren't quite working. But anyways, you can see right here, 1027. So that's the total number of frames in our scene, or at least that's what this variable is. Now, that's a bit confusing because it's just a number by itself. You can make things a little clearer by typing quotations and typing in, this is the total number of frames in the quotation mark, and then just put a comma. And what this will do is first it will print this string, this text, and then it will print this variable. And it's important you have the comma here, otherwise it's not going to work exactly, but this will help you do it. So you put a comma in between any kind of variable you want to add to this. And if you wanted to have spaces between them, you need to add in a space character like that. And you could have like another variable here or something, and that will list them all out for you. So, but we just want to see these two. So if I run this and then we go over to the console, let's pull it back up. You can see this is the total number of frames, 1027. Great. So now we know how to kind of debug our code, figure out things are working, move in baby steps, how to hunt for stuff, how to use Google if we have to, and how to get where we need to go. So that's how we create Python code. So let's do this now. Let's create our little loop. Let's talk about loops. One of the most simple types of loops you can use is a for loop. And I'm going to show you what that syntax looks like. So if I have, let's see, x equals 10, and actually we'll do it over the console so you can see this at play. So x equals 10. So if I type in x, it's going to give me 10. So I'll say for count, and count is a variable here. It could be another. Let's do something like y, just so it's a bit clearer that it's a variable. So for y in, and then let's say we've got, let's go for, I think it's range is the function we need to use. Print hello. Actually, I should put that in quotations for it to work. Hello, and then comma and y. Let's see if that works. Yeah, cool, great. Okay, so the way a for loop works is that you ask for two variables basically. You have the first variable and then the second variable. Okay, it's a little confusing that we have to use this range function here. If I had a simpler version, maybe let's see. I'll say x equals, and I'm going to create an array. So I'll just put numbers in the array. So 1, 2, 3, 4, 8, 5, 2, 1. So okay, so I've got a bunch of different variables in this variable. So now x is all of those numbers. So if I create the square brackets and say, all right, give me the first entry in entry 0, it's going to give me 1. Give me the 5th entry. There we go, or it's the 6th entry technically because 0 is where it starts. So you can see how it works. So we have this variable now, x, and inside of it are all these different values, right? So now if I create a for loop, for y will be our counting variable in x. So it's going to go through each entry in x. And each time it goes through an entry in x, it will assign it to y. So I can go print y. And now it's going to print y each time. So if I hit return, you can see it'll give me 1, 2, 3, 4, 8, 5, 2, 1, which is the numbers that we put in here. So every single entry is going to get a turn. And once it finishes cycling through all the entries, it stops. And it will do whatever it is you want it to do inside. And the thing that lets it know that these are the instructions to do is this tab space that I did here. So 4 spaces is the magic number in Python. So we've got 4 spaces forward, and everything that is 4 spaces forward from this bit will be considered part of what is going to get executed here. What's the list of things that need to happen? Now, if we go back up to this one, when x was just a number, I had to use a function here, the special function called range, and this is just built into Python. This is one of the things you just have to know about, or you can Google how to use a for loop and go through, all the values in a variable. You'll find it. It will pop up. Range is what you would use. So that's how I learned this. So range is a function that will basically take a number and it will treat it like an array, and 10 will be the number of times that it goes through the for loop, and it will assign each of the numbers to y. So y in this case is going to be 0, 1, 2, 3, 4, all the way up to 9. All right, so now we know this works. I'm going to simplify this, and I'm just going to write total number of frames, and we'll just leave it like that so it's a bit clearer. So now what we're going to do is we're going to use these for loops, and we're going to loop through the total number of frames in our scene. So we're going to go through and repeat an action for every frame in our scene. So let's go for 4. Let's create a variable that's going to hold what number we're up to. So I'll just use f as that variable for frame. And I'm going to say, so for f in, we're going to use the range function, and I'm going to type in total frames. Go. And then we use the colon like that. And this will then automatically indent us. See, when I hit return on my keyboard, it put me forward 1 tab. With f, right? F is going to be 0 in this first run through on this for loop. Okay, so what we need to do is we need to set the frame. And we set it to frame 0, right? It's going to be way back here. That's not what we want. We actually want it to start at frame start. The next time we run through, it's going to be 1, right? And where do we want it to go then? Well, we want it to go to frame 447. Okay, so you can see the pattern. What needs to happen is every time we run through this, we need to take whatever value is in f and add it to the start frame. So 0 plus 446 is 446. 0 plus or 1 plus 446 is 447. Let's take a look at that in action. I'm just going to go print f. Again, this is how I recommend you do it, so you can work through this bit by bit to make sure things are working. So for f in range, total frames, print f. Okay, so let's run this code. There we go. And let's pull up the console. And there we go. We can see we've got all the different values here. We add it to the start frame. So let's grab bpy.context.scene.frame start. All right, now let's run it again and see how that looks. Scroll back up to where we were. So here we go, total number of frames, this is where it starts. So 446 is now the first number, and then it goes 447, 448, 449, and let's compare that. 446, yep, great, seems to have worked. 147, actually we're short, 1473. And that's because when we subtract the do, we lose 1 value. So that's good to know, actually. We need to actually have 1 more in it. So let's just add 1 to it here. So bpy frame end minus frame start plus 1. That way we'll get to what we want. So we don't need this print statement anymore. But now let's put this, f plus frame start to work. So let's go ahead and set the current frame to this. So bpy.context, we just copy actually, it's quicker. Let's go to our little palette that we've made down here, paste this in, frame set, and we're going to set the frame to f plus the frame start. Copy, paste. There we go. So now we're going to be setting the frame to each frame in our entire timeline sequentially. Great. Okay, now what do we want to do when we move to a frame? So when we get to the first frame, we set it, and now what we need to do is render the frame. So let's grab the render. Where is it? Here we go. And paste this here. Now this operation is going to use whatever settings you have set up over here. So we got to make sure we set those well. So let me just create a new folder so I don't save over my other stuff. So now I know if I run this, it's going to start to render the whole thing, but I also have to be careful because there's nothing that can stop this, right? So if I want to test that it's working, I should probably come over here and just set my frame in to like 448. So it's just going to render like 2 or 3 frames, right? So let's do that and see if it works. So I'm going to click this and click go. It's done. Okay. So don't know if it's done. I'm assuming it's done. Let's open up our folder and just have a quick look. There's our folder and it's empty. All right. So something didn't work. What didn't work? I don't know. So you're going to run into this all the time when you're creating code. You're going to have to like try and solve these problems because it makes sense here. It's like, why wouldn't that work? Now, the reason for that is you need to just come back and go, okay, well, what is this command telling Blender to do? Do it manually. So, okay, I'm going to come up, I'm going to render image. Okay, so it's rendering, takes some time, and I've got an image. What's the next thing you have to do usually? Well, if I want to keep this image, I need to go image, save, and save the image somewhere. And then I have to enter in some values and whatever. And that's the problem. So what our code's doing is it's going through each frame and it's rendering it, and then it goes to the next frame and it renders it again and it puts it over it on the slot. And so it's just constantly rewriting over the same image and it never saves any images anywhere. So you don't get what you want, right? So that's the problem we got to figure out. So in this particular case, what we want to do is have an operation that we can run that's going to render the frame and save the file, right? Now, there are ways to do that in the code, but one way that's pretty straightforward and simple would be to come up here and go, okay, well, what if we just rendered the animation, but only rendered one frame? Let's try that. So I'm going to copy the Python command here for rendering animation. And I'm going to come up here and I'm going to set that to the command. Now, if I run this now, it's going to render every frame in my whole timeline each time it cycles through this loop. So I'm going to get a lot of images rendered. It's going to take a long time and it's going to be really frustrating. So this isn't quite what I want to do. I'm going to get rid of our little debug print statement. What I want to do is here, I want to actually set the frame start and the frame end to be the frame that we're on. So we're basically changing our timeline every time we run through this loop. So when I run this animation render command, it's only going to render the one frame, right? Haha, there we go. We've tricked Blender to do what we want it to do. And that's what you're going to have to do when you're creating Python code. Now, as you get more and more advanced, you might find better ways of doing this where you can actually set a render off just directly within the code itself. The way to do it does exist. So, but as you're learning and kind of poking your way through it, sometimes these solutions are the ones you have to work with. And they're not necessarily not valid, right? They still work. Right? Sometimes they're a bit slower to calculate, but that's fine. You don't have to make this most optimized code in the world. So let's go in and make that work. So what I'm going to do is I need to change a couple of things. I want to set the start and end frame to be something new each time. So I should probably save the original one, save the one that we start with so I don't lose that. So I'm going to drag my end back out to where it needs to go, which is somewhere out here. That's right. I think right around, it's like 1490, let's say. And I've got my start frame. So let's save start and end as variables, okay? Let's do that first, way up here. So let's say start frame and end frame. So start frame is going to be equal to BPY context frame start. And end frame is going to be the same thing, but frame end. So I'm just going to copy that, set this equal to, and frame end. So we've stored those, okay? Now, what we can do down here is when we begin our little loop, we can set the frame to what we need it to be. And then what I want to do is I want to come over here and I want to set the start and end frame to be just one off of each other. So what we can do is, let's think about that. Probably a cleaner way so we don't have to keep typing BPY all the time, is to create a variable at the beginning. So we're going to call this render frame. And render frame is going to be f plus what our original start frame value was. Start frame. Now, by using this variable, if we change the actual start frame to something else, then it won't change this number too. This number is always going to stay what the original one was, and that's what we want for this. So that's the correct render frame. So now when we set our current frame, we can actually use that variable. Render frame, there it is. And now what we want to do is we want to set the start and end frame. So the start frame, we want it to be, so let's go BPY context frame start, copy that, paste this, and we're going to set it equal to render frame. Copy this, copy, paste, underscore end equals render underscore frame. So now it's going to set the start and end frame to the render frame and set the current frame to the render frame. Now, if I execute the render animation operation, it will render the frame that we're on, save the image for us, and stop. And then it will go back up to the for loop and run to the next one. And because f changes each time, going up by 1, this render frame value will change by 1, and we will set the frame to the new frame, set the start, the end to that frame as well, and then run the executed command. So we've just built our own custom renderer right here, right? We can execute the render command now on a per frame basis. But now we need to get a little bit more information. We need to know when to change this, the motion blur setting. That's the whole point of this, right? So we need to figure out when does render frame equal the frame before one of these markers or the frame that the marker lives on. So actually, the only thing that's important is the frame before, because that's the only time we need to switch it. Every time else, it can be start frame for the motion blur. So let's go ahead and add that start frame in, because we know that that's what we want. So I'm going to, again, right click, and actually can't get that Python code over there, but we've brought it already. So I'm going to grab BPY context scene EV motion blur position equals start. I'm going to copy that. And let's just set that right here before we render. So every time it's just going to set it. If it's already set to that, it's just going to reset it to that and do the render. So all we need to do is change if it matches a certain number. So let's go collect the numbers that we need. Okay, so I'm going to create a comment. And what we're going to do here is we're going to loop through every marker and save the frame number. So we're saving the frame number of every marker. Actually, before each marker, because that's when we want to switch the position of the motion blur. So we want to grab the frame number before each marker. So let's loop through every marker. How do we do that? Well, let's use a for loop. And let's create a variable, maybe im, or we call it marker, we call it anything we want. We'll go im, actually call marker. That'll make it more sense when you look at the code. So for marker in, and then let's grab all the markers. So we know that this is the code, BPY context scene markers. Notice I didn't copy the square bracket. So it's going to grab this array. Remember, timeline markers is an array holding all the markers in the scene and a bunch of information about them. So we're going to cycle through each of those. And so now, because we've basically assigned, this is the same as going, all right, on the first run through, it's going to grab marker in index 0 and assign it to this variable called marker. So remember before, if we typed in like frame, for example, after this, it would look at marker, the first one in the set, and it would look at what's the frame number that it's on. It would print that out for us. So what we've done here is assigned all of this to this right here. Sorry, we run through the first time, we've assigned all of this to that. So now if I go marker and I grab that variable and then type dot frame, that's the same as doing this, right? Timeline markers 0 dot frame. Or for the next time we run through, timeline markers in slot number 1 dot frame, slot number 2, slot number 3. So I'm going to go through each of those. So by assigning each of those entries in timeline marker to this thing means we can do all the same commands that we would on that. So that's a cool thing about Python. It's like creating a new name for this shortcut. It's like a shortcut, like in Windows. Like if you would have a shortcut to another directory somewhere. Marker has become a shortcut to bpy.context.scene.timeline_markers. Okay, so I know you're still with me, right? Having fun, like and subscribe, all that. Okay, so we want to store what? We want to store the frame before of these. So that means we need to get the frame of each of these markers. So we want to say marker.frame -1, right? Because that will give us the frame of the marker, and it'll give us the frame before it. And we want to check, is this equal to whatever this number is for each of these, okay? But we need to store these somehow, okay? So how are we going to store these? Let's store all of these frame numbers inside of a variable. Now, because we need to store a bunch of things inside one variable, it should be an array, right? So let's call this array marker frames. And we don't want to assign anything to it yet. So if we want to create an empty array, we can just do the square brackets. And now we've told Blender, make a variable called marker frames. It's going to be an array. So get ready for that, but don't do anything with it yet. Now what we're going to do is we want to assign this value, so marker frame -1 to it. So to do that with an array, there's a special command we need to use, okay? So I can show you how to find that out over here. Again, if we come back to our little console, and let's see, is X still there? Yes, we still have X, our array. If I create a new array, let's call it marker, right? And I'll just create some random frame numbers. Let's call it 445, 478, 2000, right? So these are the frames of my my markers, right? Marker. And so in entry 0 is 445. So if I come over here to entry 0 and then hit the dot key, or actually before we even go to the entries, if we just go to marker itself and hit dot and hit tab, it's going to give me all the different commands or the different things, operations or functions that I can run on this array. So I've got a couple of cool ones here: append, clear, copy, count, extend. You can see you could figure out what a lot of these probably do. Reverse, sort. Append is the one that we want. So let's type in append and hit tab. You can see here, append object to the end of the list. Ah, that's what it does. So I'm going to add these numbers to a list. So I'm going to do that. I'm going to go marker frames dot append and then do the curly parentheses. And what I want to append is the marker right here, this variable, dot frame. So the frame of the first marker that or whatever marker we're going through in this. And we want to minus it by 1. So we get the exact frame number minus 1, which will be the frame that we want to change our motion blur position. Cool. Now at the end of this, all of these will be stored into this variable called marker frames. And after we've gone through this loop, we could test it, right, by going print marker frames. And again, just so it's clear, let's tell ourselves what we're looking at. So quotations, marker frames equals space, and then that, and then a comma, and it will run through and it will print all the different entries. It'll look like this, basically. It'll list them all out. Now, we've got all this code, which we don't necessarily want to run through because we don't want to render our whole thing yet. So what we could do is just temporarily is comment it out. And now it's not going to run any of this code, and it's just going to do this stuff here. So if we run this, oh, we've got an error. What's that? So this is what errors look like. They pop up, this little thing, and it tells you some information. And it says it's in line 8, name error, py not defined. Did you mean bpy? Oh, okay, let's find it. So line 8. Go to it, and it's even here. Look, 8 is highlighted, and I can see the error. I forgot to copy the full command. Wow, glad it told me. There we go. Now I fixed it. So that's what an error looks like, and they're going to pop up often for you. Little bugs happen all the time from typos, and so it's really good to tell you where it happened. You can navigate to it and figure out what went wrong. So let's try it again. Hey, it worked. All right. So let's go to our console and have a look. There it is. Total number of frames. Oops, there we go. 10,000. Or so 1045, and marker frames equals, and there they all are. Let's just double check these values. So 447, 443, 504. Let's look at 447. So let's go to the first marker here. So the first marker happens at frame 448. So that value minus 1 should be 447. And yep, sure enough, that's exactly what we see here. The first one is 447. Next is 473. So let's just double check that. 474 minus 1 is 473. Yeah, it's working. Great. So we've got all of our camera markers. Now, one thing you got to think about sometimes is there's scenarios you might not anticipate. Like, for example, if I go here at 464 and hit M, I've put a marker in my scene, but it's not bound to a camera. Okay. So let's run our code now again, and you'll see if we go over here. The third one in is 504. Let's see, do these match? 44, 473, 504, 503. Yep, so right here at the end, you can't see it because it's off the screen. Just make this a bit smaller. So you can see the second time we've run the code, there's another entry at the end here, 463. This tells us two really important things. One is, currently, our code doesn't know if the marker is bound to a camera or not, which might be important because we don't necessarily switch the way we're doing motion blur if we just run into any old marker. We only want to do this with camera markers. Switching on other ones will create inconsistent motion blur within our shots. The other thing to note is that notice it didn't put it in the order that it happened. It actually put it in the order at which we created it in Blender. So this new one happened right at the end of our array. That means that these frame numbers are going to be out of order. They're going to be not in sequential order, they're going to be order in which they were created. I mean, if you're creating on a project for a long time with lots of markers, these numbers are going to be all over the place. So that means we need to order these numbers in a way that is sequential. And we also need to check to see if it's a camera. So we need to use an if command. So if is a conditional test. So let's have a look. Let's grab some markers. I'm going to create here marker equals bpy dot context dot scene dot timeline markers. So now we've got this new variable called marker, and I can check out marker 0, and I can check out which camera it's bound to, and okay, there we go, camera wide, blah, blah, blah. Okay, so let's find out how far can we go there? Where's this one that we made? So it's gonna be at the very end. So what I can do here is actually use an operation here called len. There's a little operation called len, which is short for length. So if I run that on marker, put marker into it, it'll tell me how big that array is. So it's got 22 entries. So that means if I go to marker square bracket 21 dot name, I should get F464, which, yep, that's the name of that marker. But if I go dot camera, because remember the other ones, we can go dot camera to find out the camera name that's bound to it. You can see this is a command that exists for this marker. If I hit the return key, nothing happens. So it returns with nothing. It's like an empty thing. So there's no camera associated with this, and we can use that. An if statement is basically a condition to check if something's true. So let's make x equal to 0. Okay, so x is now 0. If I go if x is equal to, and notice I put 2 equal signs. If you're checking conditions in an x in an if statement, you have to use the double. You'll get an error otherwise. But let's make this simpler. Let's say if x is greater than 0 colon. Now it's just like a for loop. We have a indentation, and now we're going to execute some code inside this. So if x is greater than 0, print yes. And didn't print yes. Let's go back up. Let's try that again. If x is, let's see, less than 1, print yes. There, yes, it works. So it is less than 1. Now, if you want to say you test if something is equal to, you don't just put equal to. This won't work. So you see we get this syntax error, and it tells you maybe you meant double equals. And basically what it's saying is if you're checking the condition of something, you don't use the single equal, because that's only when you're assigning the value to a variable. So just follow the instructions there, and you'll do 2 equal signs, and that's when you're checking if something is equal to something. So now it will work, print yes, and it won't print because it's not equal to 1. Okay, so that's how if statements work. So we can use this to check what's going on. So let's come back over here. One cool thing about this, I'll show you this over here actually. So if we go back to markers, we lost it. That's all right. We'll just reassign that. Markers equals bpy.context.scene timeline markers, and then marker. So let's check this. So if marker, and let's just go for the first entry, dot camera, and I'll just do the colon there, right? So print, and yes, there's a camera. We run that. Hey, it worked. So basically when you're checking, you can use these things. So this returns a name, right? We know that marker.0 returns a name. So if I run that command by itself, bam, you can see it returns a name, C01 V1 wide. Anyway, so because it returns something, it's basically like saying, hey, this is true. It's got something in it, right? So by testing it with an if statement, we can find out if something exists inside a data block or not. So if I change this to 21, which we know is the one with the marker without a camera, and I run this, print, actually I'll just go down there, I print, yes, there's a camera. Well, we didn't get anything. We also didn't get an error, which is important. It means it works. That's something we can use to test. So we want to test that here. So we're going to be here to our markers. And before we assign things to marker frames, we want to check if marker.camera, then do this. Now, you can also do something called an else. So we do else, and we can create another code here for like if it doesn't meet that criteria, do this instead. But you also don't have to do that. You can just go if, and if this condition is true, it will do this. If it's not, it will just go to the end and realize there's nothing else and go back to the for loop and run the next one. So that's how we're going to make sure we just have cameras. But now the next thing we need to do is we need to resort them, right? So they match. Well, we probably don't need to resort them, but we can. We can come over to marker frames here after we run our for loop. So you can see because this isn't indented, this won't be included in the for loop. This will execute after the for loop finishes. And I can go, I type dot sort and do the open close bracket. Now it will sort this based on the order, and then we'll print them for us. So let's just run that and have a look at what we get. And here we are. You can see no longer does it end with 463. In fact, 463 is now gone from the list. And also you can see that these are all numbered sequentially. And we can check this right over here where we're going to set the EV motion blur position. So if the, let's see, what are we looking for? So if render frame is equal to, there it is again, the double equal sign. Now what's it going to be equal to? We want to find out if it's equal to any of the values that are stored in marker frames, because all the values in marker frames are the values that we want to be setting our motion blur to end of frame. But how do we do that? Well, we could set it like this if we only had one value. So if we were just always testing if it was the same as marker frames, the first entry, this would work, right? We could run through and every time it would check, does render frame match the first entry of marker frames? Nope, 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 nope. Yes, change the motion blur position. So we would want to change that to end for that one instance. Copy. And then we could say, okay, if it doesn't equal that, then we come over here and we go else. And let's grab the other one. And the way this works is it'll test every single render frame value. And if that render frame value matches the first entry of marker frames, then it'll set it to end. And if it doesn't, then it'll do this one. Instead, it'll go, okay, well, then we'll make it start. And then it will render. Okay. So, but we want to test more than this. Now, because marker frames is an array, there's another command we can use to look inside all of the array. So we're going to say if render frame in marker frames, then do this. And what this little in keyword, there you see it turned red, basically does, it's a command that will look inside of an array. And it will compare this value to all the values in there. And if it finds a single match, it'll run this bit of command, this bit of code. If it doesn't exist, if the frame number, it doesn't in there at all, then it won't run it. It'll just run this one, and then we'll have our render. So I think we've done it. Let's test our code and see if it worked. So if you remember back here, we had the motion blur problem when we got to this frame. So from here to here. So I'm going to make sure I've got myself set on start frame. And I'm just going to set my first render frame here to 472. So I'll just copy that, paste that, because I just want to test this with a few frames. And let's see. Oh, wait, that wasn't it, was it? It was, where is it? This one right here. So this metal sheet was our test case. So I'm going to go 524. And I'll go forward a few frames to here, maybe 529. And I'm just going to test this little bit right here. Okay. So I've got all that stuff set. I think we're all good. And I might just save this. And I'm also going to save my my Python file here. This is important actually because you don't want to lose it inside your Blender file. It's a protected data block, so it's not going to go away. But if you go text, save as, then you can save this somewhere. So motion clear, but we can save this as an external Python file, and that way you can open it and load it into other ones a bit easier. So, okay, you ready? Let's find out if it worked. Drum roll. We should print in, let's add in some print statements so we know that it's working while it's going. So there we go. All right, let's see what happens. I'm going to run the code. And I'm going to pull up my console. We can see here. It's going to give us a little readout as we go. All right, so it's all done. And you can see we've got all these different printouts now. We can see that rendering frame 526, blur set to end, 527, set to start, 528, set to start, 529, set to start, and success finished render. So it looks like it worked. So let's just have a look. Cool. So here we are. We've got our renders. So 524, 525, 526, and bam, there we go. It's a consistent cut. So we no longer have the motion blur problem. So our code worked. We were able to create a tool that we can use now to render from that's going to automatically fix our motion blur as we go. This is very exciting. And I hope you were excited. I hope you feel really empowered and you learned a lot about how you can use Python to automate stuff and how you can kind of figure your way through it. So hopefully this was a really helpful tutorial for you. If you enjoyed it, please hit that like button. Don't forget to subscribe to the channel and check out Patreon. Now, if you check out Patreon this week, what I've got is I'm going to take this code and go a bit further with it, and I'm going to explain how to actually turn this into a button that you can click and have it as an add-on that anyone can install. Okay, so if you want to learn how to do that, consider heading over to Patreon and joining there, or you can join on YouTube as well. The all access pass level and higher, I'll have this full uncut version there for you as well. A lot of extra stuff. All my tutorials have an uncut version with a lot of extra stuff. So if you like extra content and you enjoy my channel, consider signing up there to help support what I'm doing. Thanks so much. If you want to get this project file, actually not this project file, but the add-on that I finished making, you can head over to Patreon, and if you join at the second tier and up, you'll be able to get that add-on as well, along with all the project files for the month. So check it out. Thanks so much. Catch you in the next one. See you later.